Greetings and welcome to my new calculus channel. My name is John Gabriel. So, in this video, I'd like to talk about how math professors and teachers need to be retrained on how to perform division and, more importantly, to understand it. So, in this brilliant presentation, which is, let's see, how many slides? Which is about 29 slides, I teach these incorrigibly stupid morons how to understand these things. Okay, so most of my articles and videos expose academic ignorance and stupidity, but in this presentation I will focus on how to teach these misguided, misled and ignorant fools who are called math professors and educators on what it means to perform division. And hopefully this content won't be too advanced for them, and perhaps I'll have a little bit of fun too. So I start off with the first slide. Division is a form of measurement. What measuring unit is being used in the diagram above? Can you tell? Can you form a division equation to illustrate this? Don't cheat by looking at the next slide. Click pause button now. Okay. Well, answers. The unit of feet, of course, you idiots. That's what is being measured here. How many feet this bench has, okay? And the equation is simply 3, or 3 over 1 is equal to 3 divided by 1, okay? So division tells us the measure of one magnitude in terms of another. If we use the foot as a standard measuring magnitude, then we observe there are 3 feet that describe the length of the table. We should write 3 over 1, but we know by convention that this is what is meant by 3. So we could also write a line segment that is 3 equal parts, and in the antecedent part, and 1 equal part in the consequent, or as 9 equal parts to 3 equal parts, right? If we still hadn't invented digit symbols 1 and 3. So how would you write 1/3 without digits? Well, there are many ways to write it, but here are 2 examples, okay? 1 to 3 or 2 to 6. And what does 3 divided by 1 mean? It means that 3 is being measured by 1. In other words, the larger is measured by the smaller, okay? And 1 divided by 3 means that the smaller is being measured by the larger. So when we write 1 over 3 or 3 over 1, the division has taken place. There's nothing outstanding. There's nothing pending. Both of those are valid representation of the well-formed numbers that describe the measure of respective magnitudes. So here's a nice little quiz, which I won't do, but you can do, and I'll place a link to this article. If you're a math professor or a math teacher, sit up straight and pay attention. Stop scratching your nose and your rear end, and stop doing all the juvenile, stupid things that you do in high school and in college, okay? And also, please do not abuse your male students. That is a very big no-no. A lot of you are homosexuals, and you need to leave your male students alone because they're there to learn, not to be abused by you. So in the previous slide, all of 3/4, 6/8, and 9/12 represent the same number, but the measurement in each case is done with a different unit. That is 4, 8, and 12, okay? So in other words, in 3/4, we have 4 equal parts of the unit, and only 3 of those parts is the measure. Similarly, 8 equal parts, and only 6 of those is the measure. So 9 over 12 does not mean 9 divided by 12, okay? The division has taken place. This is a well-formed number. So in geometry, it is possible to divide any line segment into n equal parts. In algebra, nothing happens when the smaller is measured by the larger. In the case of 3/4, or 3 divided by 4, which happens in the past, 3 goes to the top of the vinculum and 4 to the bottom. Nothing else happens, okay? In algebra, nothing else happens. All you do is you take the first operand and you put it on top of the vehiculum and the second operand at the bottom. And it doesn't even matter if this operand is less than or greater than. In algebra, you can still put any division in that form. And then, of course, if the numerator is greater, you can simplify it. And of course, that's another issue entirely. Okay. So here's a challenge question for mathematics professors. In this slide here, this previous slide, all of 3/4, 6/8, and 9/12 represent the same number, but the measurement in each case is done with a different unit. That is a unit that is composed of 4 equal parts, 8 equal parts, and 12 equal parts respectively. Thus, to measure the ratio 3/4, we use 3 or 4 equal parts of the unit. Okay, and to measure the ratio 6 to 8, 6 to 8, we use 6 of 8 equal parts of the unit. So the final measure is the same, but the process of getting there is slightly different. I mean, in all these examples here, you're doing the measure differently, even though the final outcome is the same, right? You're saying 3 equal parts of these, or 8 equal parts of these, or 12 equal parts of these. That's what it means to write a fraction, by the way. Did you know that? Yes, I know. After you got your PhD, you still didn't know this because you're fucking morons. But I'm trying to educate you and bring you up to scratch. Okay? So listen to me, sit up straight, don't fondle your students. That is an absolute no-no. Do not play with your students' reproductive parts, especially your male students. They're not like you, most of them at least. So write a short essay that addresses these aspects and say how the abstract unit is the way measure is done in algebra. Okay? Your essay should point out 2 important facts. The type and size of the unit in algebra is irrelevant, and the measure is generalized to an abstract unit that is divided into equal parts. Okay, that's the difference between algebra and geometry, you morons. The measure is found in terms of the whole abstract unit and or parts of it. Right, I would give a bonus mark to anyone who can define number without any contradictions and using only well-formed concepts. The answer to the bonus mark is found on the next slide. I'm going to skip it. Okay. All the properties of fractions and their arithmetic operations are described in the Elements, Book 5, and Proposition 12. Similar triangles are used to demonstrate all the arithmetic binary operators, and these are all explained in this video here. What does it mean when you convert a quarter into decimal? It means that you measure it using the decimal system, okay? So what it means is this, that you're actually finding a measure in tenths and hundreds or thousands, etc. And it doesn't go on forever. It has to end because measure of division is a fixed number of steps. There's no such thing as something goes on forever. Nothing goes on forever except your infinite stupidity. Okay, so, and it really does not matter how you perform the measurement, provided you remember that the divisor measures the dividend to produce the quotient. Okay, so here I give an example and explain what these terms mean. Sit up straight, you morons. Pay attention. 4 is the divisor. 2/10 plus 5/100 are the partial quotient. The full quotient is 25 over 100. I could have split this dividend up also into partial dividends if I wanted to. I could have said 1/3 plus 2/3. Doesn't matter what you put in here as long as the answer is the same. Okay, it's a measure and it terminates. Because, I mean, division is a finite measure. Nothing goes on forever. So I explained the process to you in these numerous other slides, and I also show you how this applies to your long polynomial division, okay, or polynomial long division, and why you're able to do the things that you're able to do there. And it takes genius to understand these things. Most of you are absolute buffoons, so you don't know these things. But if you ask nicely, I'll be able to tell you more. Now, below are just a few ways to show 1 divided by 3. 4 ways only. Okay, and the rightmost is an example as a measure of 1/3 in base 10. This, where I'm pointing to now, is how you measure 1/3 in base 10. And look, there's no remainder there. Do you see that? Are you surprised? Really? You see that? Does that shock you? Yes, moron, it does shock you because you've never understood what the fuck division is. You don't even understand what a number is because you're so fucking stupid. So, did you notice there is no remainder in any of these division examples? There's a good reason for that. You don't get to infinitely divide by 3. There's no such things, you brainless buffoons. Your boorishness has no limits. Division is a finite and complete measure. Nothing goes on forever, okay? Except, of course, your infinite thickness, denseness. In the diagram below, I show you how it is possible to find an equivalent fraction for any given fraction using geometry. That means if you had to do something like this where you want to find a ratio of line segments, forget about the numbers here, just a ratio of line segments, and find an antecedent for this orange line, it would be this magenta part here, and you can't measure it. Okay, you can try to measure it, but there is no measure of it. How do I know? Because there is no measure of 1/3 in base 10. And this article here, proof of the most important number theorem, that you morons never learned, is what you need to access and understand why 1/3 doesn't have a measure in base 10. No, not finite, not infinite. Okay, it doesn't have a measure, period. So now you might turn around and tell me, well, what about these here? Well, these here are not actually, what I've done here is not actually a contradiction to what I've said, because even the right part here, this 1 over 300 is not in terms of an integral power of 10. So what I'm telling you is still true, except that I'm showing you that it's a finite operation and that there are innumerably many ways to do this. I could have carried on this division here, by the way. I could have set up here 300ths and then continued and stopped whenever I felt like it. But wherever I stopped, there would be no remainder, okay? Because this here is part of the quotient, okay? It's the last part of the partial quotient. And that's a thing which that thick idiot Isaac Newton and Euler didn't understand. And so it's surprising that they didn't understand these things because they knew what I'm about to tell you now, that you can write A over B plus C as generally as this expression here, okay? And you can see that if you study that, there is no way you can no way you can toss away this last term. If you do, then it's no longer true, okay? Then this left side is not equal to the right side. So, I mean, if I were a moron like most of you and dropped the last term, I would have a wrong answer, okay? And of course, most of what you do is wrong and misguided and ill-formed and stupid because naturally you're natural born morons, especially my fellow Americans. They're the biggest idiots on the planet, and they suffer the most from that comical, unscientific, what do you call it, mental disease or effect, the Dunning-Kruger effect. They all imagine that they know better. Fools like that idiot from Houston, Texas. What's his name again? Kerry Solow. An absolute buffoon. He thinks just because he worked at NASA that he's pretty smart. And then the other idiot who was working at Boeing, and he also too imagines that no one can tell him anything. Sit up straight, morons. I'm telling you, I'm lecturing you, I'm teaching you, I'm trying to get you to be smarter than you are. Okay, that's pretty much it. I guess I've talked enough. I'm going to put a link to this article. It's very important, especially if you're a math professor or math teacher. And please, to all the male math professors and teachers, do not play with the reproductive organs of your male students. That's very important too. I know a lot of you like to do that. That is a big no-no. All right. My name is John Gabriel, and before I sign off, if you're not already a subscriber to my channel, become one. And click like, especially click like, because these fucking idiots I've been trying to educate are going to downvote this video. And it's such an important video which is a shame that, future production line morons that come into the teaching or educating business may not be able to have access to. So make sure you click like. Also, follow me on academia, tell your friends about it. And lastly, but not least, this is very important. Submit this article to your mathematics lecturers, professors, and your teachers, and tell them to study it carefully and then explain it to you if possible. All right? Till next time, this is a New Calculus channel. Goodbye.